Hey everybody, this is Alex Merced from AlexMercedCoder.dev, and in today's video, this is the third part of our Intro to React 18. Technically React 18 101, because I did a React 18 series, I think, late 2021, when 18 first came out. But here we go. Let's just continue on. Okay, so last week kind of went over like how JSX works. So we just kind of like just talked about how we can like kind of sketch out what we want to show up on the screen. And yeah, so now let's talk about state. State's going to be sort of the other sort of big way data shows up. So the way I would always think about it is that there's props. So again, props gets passed in from the parent component. So in this case, like example is being used inside of app. So example is a child of app. And the parent can pass the child data via props, because basically since we are using that component in the JSX, that we can pass data to it. But there's no way to pass data up, and we'll talk about that in a separate video. Okay, but what happens about data that's inside a component? So let me just kind of erase all of this. Okay, so imagine this. We're going to have a variable called counter. Const counter equals, actually let's do let counter because we want counter to be reassignable, equals 1. Okay, and I want that to show up on the screen. So I will do counter. Okay, so now let me actually run the server, npm start. Okay, and then it's going to show up. And see there you see 1, right? Cool. Now what I want to do is I'm going to make a button. So we'll make a button that says like add 1. And I want this, every time I click this button, for that number to go up. And then I want that in the next line. So I'm going to put a little BR here. There we go. Okay, so that's right there under the 1. Okay, and I want every time I click this button. So first I need to make a function for that button. Okay, so here in the app component, I will make the function for the button. So I'll say like const add 1 equals an arrow function. And every time you click this function, and actually I should probably put this after we declare the counter variable. What I want to happen every time that we click this button, I want to take that counter variable and add 1 to it. So we're going to add 1 to the counter variable, and then I want to console.log that counter variable. Okay. So now I want this function to happen every time I click this button. So the way to do that in React is I would do on click. And again, notice that any sort of built-in HTML attributes, so anything that would transfer over from HTML, is going to be camel case. So something like on click is camel case. So same thing would be like on submit, on change, all those events from normal HTML are now camel case. On, then the next word camel case, equals, and then I use the curly brackets to pass it the function, add 1. So I'm going to say, hey, every time we click this thing, you're going to do this add 1 function. Now let me open up my console so you can see the console log that we put here. So again, every time I click this button, this function is going to run. So I click add 1, and we do see like, hey, look, 1 did get 1 added to it. So see, it's worth 2 now. And if I keep clicking this, see 3, 4, 5. So I am technically adding 1 to the variable. The variable is changing, but what happens is that the component isn't rebuilding the HTML on the page. So even though the variable is valued at 5, the actual text on the HTML document is only still 1 because it's not updating that. So there has to be a mechanism to say, okay, hey, when this variable changes, update where it's used in the JSX. And that mechanism is called state. So what they are is really, state is just a variable that when it changes, update what's on the screen. Okay, so let's talk about that. So how we would do that? Well, from React, what we're going to do is we're going to import. So I'm going to say import useState from React. Okay, so basically this is, anytime you see this like this use something, that's called a hook. And a hook are these things that you can use inside your functions, your function components, to do certain things. In this case, create a state variable. So create that variable that when React knows when it changes, we should update what we see on the screen. So let's recreate that counter variable. And the way it would look like is I would create the variable. This time you can just use const Because you technically, what's going to happen here is that you're not changing the variable. When we use state, what we're doing is we're updating. When we update state, what's happening is that it's updating the value of the variable on the next go around. So essentially what's going to happen is that this function is going to run again, but on the next run, the value of counter is going to be something different. So it's going to be a separate variable in a sense. So instead of reassigning a variable, we're declaring what it should be on the next run. So the way we do that is we're going to say counter, and actually you're going to use destructuring. So we're going to use array destructuring. So first let me just demonstrate something. So what I'm going to do is I am going to comment this out real quick. Okay, and we're going to just say const counter equals useState, and then in useState you pass the initial value of the variable, which is 1. So let me just console log what we get back from useState. So we're going to console.log counter. So we can see what the return value of useState is. So if I console.log and I refresh this, okay, notice that when I console log counter, see it's not 1, it's an array, and the first thing in the array is the actual the variable that has the value 1, and the second thing in the array is a function. We'll talk more about that in a second. So this is why we don't want to save that array in this variable called counter. What we want to do is actually have that first thing in the array be in counter, and then we'll save that function somewhere else. That function actually is the function you use to change the value. So what we do is we use something called array destructuring, where you can take that array and just break it up into separate variables. So I use these square brackets. I'm going to say, hey, the first thing in the array is my variable, what I really want to be counter, the actual counter variable. And the second thing in the array is the function, and that should be called, generally you call it set, the name of the variable. That's the pattern. You could call it whatever you want, but the idea is that this is clear. The idea is that this is counter, this is the variable that represents the counter as it currently is, and then this is a function that we can use to update the counter. So you never actually change the value of counter. Okay, you use this function called setCounter. What it's going to do is that it reruns this function. So this app function will run a second time, but in the second run, counter will be worth whatever we set it to. Okay, so just to kind of show you that, let me uncomment this out. Okay, and now instead of using counter plus equals 1, we're going to say set counter, and we're going to say set counter, and we're going to set it to whatever the counter currently is plus 1. Okay, now here's the thing, when you generally use, this will work, so this will technically work. So if I do this and I refresh this real quick, if I click add 1, see it goes up to 2. But notice I console logged 1. Okay, so even though I set counter and then the console log happens after I set counter, technically I never did change the value of counter. Okay, what happens is that React waits for this function to finish. When this function's done, this function here set a queue to React, said, hey React, when you're done doing whatever you're doing at the moment, I need you to rebuild this component. So the rebuild happens after the function is done, and on the rebuild, the function is now then the component is going to be 2. And let's just create a console log to kind of demonstrate this. So we'll say console.log. I'm going to say, component rendered. So this is when the component gets rendered to the screen, because any console logs I have here in the body of the function, they're going to happen when the component first generates. Okay, and then we're going to log counter. And then down here, we're going to add a little saying here, saying, add 1. Okay, and then let's refresh. So you see now when the component just initially rendered, the value is 1. Okay, so we know that its value is 1. Now if I click add 1, see, when the add 1 function runs, because it's still the previous render, so it's technically it's still the original version of the function. Then what happens is that React is queued to rebuild the component, so it reruns the function, except this time when the function runs, counter is worth 2. So when that app function runs a second time, this console log runs again, and on this initial run of the function, in that context, it's 2. So again, what I'm really trying to drive home here is that when you update state, you're not technically updating the variable that existed. You're rerunning the function, and in the context of the next run of the function, the value has changed. Okay. And again, it's going to wait for the function to play out because there might be other state changes in that function. So it's going to wait for it's going to basically wait for that function to play out in case there's any other state changes, so it can do all those state changes and batch them at the same time, meaning do them all at the same time instead of rewriting the function on every, which is what it used to do on every state change. Okay, so that's what's going on there. So again, you can use console logs to kind of see that in action. I can see like, hey, technically, even though I clicked add 1, and technically since this set counter, even though that runs before the console log, counter is still 1. Because again, it never changes it. You're never actually changing the state. You're replacing the state with a new value on the next run. Okay, and that's going to be an important thing to appreciate, and it will take a while to appreciate that. But once that kind of really sits in, a lot of the behavior of how you do things in React makes a lot more sense. Okay, and the reason why things work their way how they work in a lot of contexts is make a lot more sense. And it also makes more sense why you want to rely so heavily on DevTools. Because you notice, even though I did change the value of the 2, I still got this console log of 1. So oftentimes your console logs in the body of the function can be misleading depending on where they happen. So generally my source of truth is always going to be my DevTools. So again, if I go here, the DevTools, I click on app, and see instead of props, I look under hooks, and I'll see like there's a useState hook, meaning, hey, I declared a state, and this particular state is valued at 1 currently. And if I click on add 1, see it changes to 2. So I can know for sure what the current state is by looking at DevTools. Okay, so I always know for sure what the current state is by looking at DevTools. That's also very important. Okay. Now, second thing to keep in mind when you're now the problem with me doing this state update this way, whenever the update of state refers to itself, so you see I'm referring to the original counter value, there could be a problem. What if I click this add 1 button like a lot of times really quick? You can get kind of confused because I might click it while the old version of the button is still on the screen, depending on the lag. So it can create some sort of really weird cascades. So best practice is to do this. What you do is you pass a callback, and this is what you do here is this is the previous value. So this function receives the previous value of the state, whatever the current value of the state is. And I want to say, hey, I want the new value of the state. I'm going to return the previous value plus 1. Okay, this is going to do the same thing. So if I refresh this, it's going to do the same thing. But now if I click really fast, I'm not going to run into any kind of weird issues where like I'm adding to the same number a second time, because it's always going to be based on sort of like, hey, what is the previous value of state? It's just going to more dynamically make sure that it's working off. You're going to avoid sort of weird issues that way. So generally I would do this if your update refers to the previous value. If you're just setting it to a fixed value of some other sort, like if I just set this to 2, okay, arbitrarily, then I would just set it to 2. Which leads us to the next important point. The state update will only happen if the value of the variable actually changed. So let me refresh this. So right now the value is 1, right? So state is 1, and I'm going to set this to 2. So that's a different number, so we're going to see a state change, so which means I'm going to see those console logs again. So I'll click add 1, and you see like the add 1 happened, and then the component re-rendered. Okay, but if I click this again, right now I hard-coded it to 2, so technically on the next state it'll be 2 still. So what's going to happen is it reacts to like, I'm not going to waste time. So if the state is the same, there's no need for me to run this function again. So it just won't. So you'll see like this component rendered console log won't happen again. So if I do that, it did happen. Well, in that case it did. I think it's because like it's a, technically it shouldn't, but it did. Oh, see, that time it didn't. Okay. And see, now it's not running. It's just on that initial one. Okay, but you see like it's not running that component rendered console log again. The reason being is that on every additional click of the button, the current state is 2, and I'm changing it to 2, and instead of saying, hey, and this is a way that React optimizes to make sure that you don't make your application slow, because basically if you had to rebuild what's going on the screen every single time, even if nothing changed, that would just slow down your application. But the way React does this comparison is shallow. Okay, so when I'm comparing 1 and 2, that's obvious. Like 1 and 2 are 2 different numbers. Where it gets tricky is with objects. So okay, so let's show you an example. So let's say instead of the state starting out as instead of state being a variable with the number 1, instead we're going to say the state is an object with a property called value that equals 1. Okay? So now in this case, what I want to do is technically what I want to do is show counter.value. Okay? And see, there we got 1 again. And this function doesn't want to set it to 2. What I want to do is maybe, like, let's see if I do this. If I say counter dot value plus equals 1, so I add 1 to the value, and then I'm going to set this to counter. Okay, now watch what happens. Okay, so right now, see, component is rendered. Okay, now if I hit this button again, notice, see, no second rendered console log. Because even though the object has changed, like the value in the object has changed, it's not a different object. I still use the same counter object. Because the way JavaScript treats arrays and objects is evaluating the container and saying, hey, is this the same container? So even if the stuff, it's like a house. If I swapped out the couch in my house, it's still the same house. So for React, that's the same value. So in that case, even though the property of the object has changed, it's still the same object. So it's not going to re-render. So you have to always be careful of that with arrays and objects. You want to make sure you declare a new array or a new object. So typically what you'd want to do is instead of changing the original state, this value called counter, what you would do is you would create a new. So I would say I usually like to create a variable called new state. So const new state equals, and then what I do is we say, hey, it's a new object. And it would be the same thing with arrays, and I'll say and you use the spread operator to copy the old object. So what this does is that you're saying create a new object, the curly brackets, and inside that object should be all the same things that are inside of counter, which is another object. Okay, what it does, it unpacks counter and puts it inside of this new object. So it's the same things in a new container. And then I can update that container. So new state dot value equals or plus equals 1. And then set the counter to the new state, which would be technically a new object that's not the original. Okay, so technically this is now a new object. Now watch the difference in behavior. So now if I click add 1, see, now we get both console logs. Why? Because this happens every time I click the button, but this one happens anytime the component is rendered. So this means an additional render has occurred. Before, we only got this because technically you weren't passing in a new object, so it wasn't rendering again. It wasn't making another run of the function. Okay, and again, these are some of the nuances that are always like really, really hard to kind of appreciate at first. But once these couple things click, this whole idea that, hey, the only time that the component rebuilds itself is that when I set state, the value of the state is actually a different unique value than it was previously, which means for like a primitive value, like a number, a boolean, a string, it's just something different. But for an object or an array, it has to be a new object or a new array. Then it becomes a lot easier to make sure that these updates to your UI happen when you want them to and not when you don't. Okay? Cool. Now the only problem with like this is that even if I were to like, well, this is fine, but there might be situations where a user changes the value to exactly like the same value. So let's just kind of create an example of like that. Actually, let's do that in the next video because I don't want to introduce forms quite yet. We'll talk about like, uncontrolled forms in the next video. But that's what state is. So again, basically what you do is you create a variable using this pattern. But again, we have to import that useState hook. And that useState hook allows us to declare these types of variables. And then anytime we use the set function for that variable, that's going to cue React not to change the variable, but to rebuild that component using the new value on that rebuild, also referred to as a re-render. Okay. And again, you can see, and again, that re-render only occurs if the new value isn't the same as the old value. Okay. And again, what you pass the set counter, or the set state function, You can either pass in the new value directly, or you can pass in a callback that returns the new value. Okay, so those are sort of like the takeaways. Otherwise, it's just a variable. But the idea is that what makes a state variable unique is that there's a mechanism to say, hey, this variable changed, I need to rebuild this component. So the thought process always has to is like, hey, when this data changes, is there going to be a physical change to that component that should be visible? If the answer to that question is yes, or if like there's going to be a change to the behavior of what's going on the screen, then that needs to be state. So that way the components that need to rebuild themselves. Okay? And keep in mind, whenever a component re-renders, that means its children will re-render as well. So in this case, since this state is located in the app component, so if I go back to like my DevTools, so since this state is inside the app component, which right now doesn't have any other children, but let's say there was other children here, like the example component, all those other components I had before, all those children would rebuild themselves too. Okay, so it's cascading. So this is why generally you don't build your whole app inside of app. Okay, because then what happens if you put all your state inside of app, then literally on every state change you're rebuilding your entire application. So typically what you want to do is break your app into components and keep the state only to the components that need them. So that way when there's an update, you're only updating the pieces that need to be updated, not updating the whole app. That's how you get the maximum speed benefit from the way React is designed. Okay, and this is where generally like basically learning how to use JSX and kind of make a page and get the right HTML on the screen usually isn't too bad. This is where React becomes more difficult. I'm just like really appreciating like the nuances of state updates and appreciating sort of like best practices in the sense, again, you generally you want to keep your state further down the component tree as possible. So that way, again, you're not rebuilding as much of your application. So every time there's an update, you're only rebuilding what you need to rebuild. That's where you get the sort of best benefit out of using React. React is going to have a lot of things going on under the hood that you don't have to worry about. They just exist that will optimize those state updates. So again, it's checking to see, hey, is that state the same as before? Are there multiple state updates in this function? It's going to try to monitor that so that way it does as few updates as possible. But understanding those are going to help you write your code better so that way you make sure it updates when you need to and doesn't when you don't. Okay, so it does take a little headspace to really fully appreciate that, but that's state. And honestly, the best way to really fully appreciate state is just do this whole counter thing. Build a counter a few times, play with it, experiment with it. Change like what you change the value to. So let's say, hey, I changed this to 2, so now it's going to add 2 to the new value every time I click on it. So see, now every time it's going to go up by 2. So literally, you can create whatever kind of change you want. Okay, so hopefully you guys enjoy that. My name is Alex Merced from AlexMercedCoder.dev. Have a great day and enjoy.